Hi, hello, welcome back. Let us discuss an interesting MR spectroscopy case. This is a 60-year-old male patient who presented with a seizure episode. MRI was performed for his evaluation. Here in MRI, you are appreciating a large frontal lobe lesion, which is predominantly hyperintense with a wall which is hypointense. Here you can appreciate frontal sinusitis also. The lesion is causing mass effect and is causing subfalcian and herniation. There is buckling of the corpus callosum genu and also there is extensive vasogenic edema. FLAIR is showing the similar findings. However, edema is better appreciated on FLAIR. The signal is pretty much similar to the T2 weighted imaging. In T1, there are some heterogeneous hyperintense areas. Predominantly, the lesion is hypointense on T1 sequence. This is the diffusion, which is very interesting here. The lesion is showing areas of diffusion restriction here at the junction of frontal horn and the lesion, and also here at the wall there is some amount of diffusion restriction, and also in the center area there is some diffusion restriction. ADC showing the similar hypointense areas corresponding to the diffusion restriction areas. Here on post contrast, you can see the sinus is also enhancing, the wall of the lesion is enhancing, and some amount of leptomeningeal enhancement was seen. The mass effect and the rest of the findings are similar. Here you can see. So at this point, what are your differential diagnosis? Susceptibility weighted showing wall, showing some amount of blooming, and predominant part of the lesion is not showing any significant signal changes. So at this point, the differential diagnosis can range from any malignant neoplasm to any infection, fungal abscess, or brain pyogenic abscess, and anything. However, fingerprinting can happen with MR spectroscopy. If you see here, choline to NAA ratio is definitely not into the malignant range, that is falling below 2 in our case, choline to NAA ratio. This is a single voxel spectroscopy. The voxel placed here at the neck of the lesion. So this single voxel spectroscopy is showing elevated choline, decreased NAA, and elevated LL, lipid lactate. Lipid lactate is also slightly elevated here. However, the fingerprint MR spectroscopy in metabolite in this case is this. This is occurring at 1.9 ppm. So this is nothing but a classical succinate peak. It's an unusual metabolite you will not generally seen. It's very commonly seen with brain abscesses. So finding a succinate peak is a fingerprinting, or most probably you're dealing with a case of brain pyogenic abscess. So this is an interesting case solved with MR spectroscopy. So it can be very useful in some cases if you can find how to interpret it properly, and if you know how to check for the individual metabolite peaks, it will definitely help. So again, a borrowed case from internet where there is decreased choline, NAA, and elevated lipid lactate because of necrosis. Choline is a membrane marker for cell membrane destruction. NAA is neuronal health. Both are, so maybe there is not much of cell membrane destruction in this case, unlike our case where there would have been more cell membrane destruction and elevated choline also. Here also you are seeing a succinate peak at around 1.9. So just to create a visual impression, I am just comparing that with pigs. So succinate is a bad metabolite compared to the pus, which is fluorescent color. You can imagine and diagnose a succinate peak at around 1.9, remembering it is flowchart color coding. Thank you very much. Hope this video on brain abscess showing succinate peak was useful for you.